Today is February 26th. Yay, it's almost the end of February. I'm so excited because that's just closer still to summer vacation. I don't know if y'all are already there, but I am. I'm on summer break. It's like I'm ready to go to summer. What am I doing? We are going to spend a week at Disneyland, which is exciting. And then I've got to do some professional development stuff. And then my kid's going to have Girl Scout camp. And then after that, we go to Michigan for a month. So, outside of Traverse City.
Are you going to Chirac?
I'm sorry, what?
Chirac.
All right. So today we are doing something, solving exponential equations, which basically goes back to some properties of exponents, but also what is known as the one-to-one property. And this is the hello, don't overthink things property. It's really just the property of two things being equal. All right. So if x plus 7 equals 12 plus 7, what's x?
Minus 7.
12.
12. X equals 12. Don't overthink it. Okay. If 5 plus x equals 5 plus 10, what's x? 10. Don't overthink it. Okay, do you see that? Okay, don't overthink it. All right, it's really if two things are equal, if the left side is supposed to be exactly the same as the right side, then that x should be 10, right? To make them identical. That's what equality means. The same thing is true here. If this statement is equal, then what's x? X equals 7. If x is replaced with a 7, are they the same? Yes, they are. Okay. If 1/5 to the x equals 1/5 to the negative 4, then x equals negative 4. Don't overthink it. All right? Here is the property. Write this down. If b to the u equals b to the v, which says if the bases match, then u must equal v. If the bases match, then the exponents should have to match in order for these two things to be equal. Does that make sense to you? Okay, if the bases match, then the exponents should match. This is the one-to-one property, and we use the one-to-one property a lot coming up, okay? So that's something you step back and look at. Don't overthink it. Don't go through -5 from both sides. It's unnecessary. That's extra hardship, all right? And I try to do as little work as possible. Okay, so we are solving exponential equations. And I want to just really fast review some exponent properties. X to the 5th times x to the 7th is what?
12.
X to the 12th. You get to do what to the exponents? Add the exponents. Very good. All right, that is the property of exponents. If the bases match, then we're allowed to add the exponents together. All right. Another thing, if I have x to the -1 power, what does a negative exponent do? It makes it a fraction. It makes it 1 over x. So it creates a fraction. The same is true for fractions. The reverse is true, I guess I should say. If I have a fraction 1/2 and I have it to the -1 power, what does it turn it into? 2 over 1. Yeah, that negative exponent flips the fraction and it becomes a happy power of 1. Okay? And so negative exponents create fractions or they flip fractions if that's already there. So a few little properties we want to remember, but let's do some of this. Using our one-to-one property. If the bases match, then the exponents must match. Example 1, solve each equation. I do want to remind you that you have a test coming up on Monday. We're going to review on Friday. We have a great review for you. You will get to use the review on your test. Which means, do just answers help? No. Just putting an answer does nothing. You need to do the work. You need to show the work. You need to explain the work. You need to use your notes to help you answer the question. All right? Example 1, solve each equation. So we have 4 to the 2x equals 64. This is an exponential equation. How do I know that? What makes it exponential? X is in the exponent. Very good. X in exponent makes it exponential. And the other thing I can think about is our one-to-one property, which says if the bases match, if b to the u equals b to the v, if the bases are the same, then my exponents must match. U will equal v. So what I want to do is I want to try and this has a base of 4. And what I would like to do is I'd like to rewrite 64 using powers. And so I want to use the same base of 4. So let's think. 4 to the first is 4. What's 4 squared? 16. What's 4 cubed? 64. So I can trade in 64. What can I trade in 64 for? 4 to the third. So we can use powers to create simple equations sometimes. So we're trading in 64 for what it's equal to, which is 4 cubed. 4 cubed is the same as 64. Now, if the bases match, what must be true? U equals V. The exponents must match. 2x must equal 3. So can you solve for x? How do you do that? Divide by 2. Divide by 2. So we get x equals 3 halves. And that is the solution for x. I can take that answer and I can plug it in. So I'm going to take 3 halves and I'm going to plug it in place of x. So this is 4 to the 2 times, in place of x, I'm putting in 3 over 2. 3 divided by 2. Can you see that? There we go. It's a little better. And I get 64. Hey, it worked. Okay, so you can always take your answer and plug it back in to double check. All right, let's look at letter B. 5 to the x plus 4 equals 1 over 125. This has a base of 5. So what I'd like to do is rewrite this right-hand side using a base. How do we create a fraction? Negative exponents. Yeah, so let's think. I want to use a base of 5. 5 to the negative 1 equals what? 1 over 5. What's 5 to the negative 2? 1 over 25. 1 over 5 squared. 1 over 25. What's 5 to the negative 3? 1 over 125. And again, these are things you can plug into your calculator. If you're not sure, 5 to the negative 3 gives me a weird decimal, but I can change it to a fraction. 1 over 125. All right, you can math frac that, fraction decimal that. So what can I trade in 1 over 125 with? 5 to the negative 3. I am writing things with the same base. Now, if my bases match, what must be true? U equals V. The exponents, x plus 4 must equal negative 3. And then you can solve for x really easily. So we can turn this exponential equation into just a linear one, which is super nice. What do we need to do to isolate x? Subtract 4, so we get x equals negative 7. Okay. Questions so far? Um, 7 to the 3x minus 2 equals 1. So my left-hand side has a base of 7. What I want to do is rewrite the right-hand side so it also uses a base of 7. 7 to what power equals 1? Oh, 7 to the 0 equals 1. That's absolutely true. Always, always. Ones are nice. So 7 to the power of 0 is the same as 1. And if we know that the bases match, what must be true? U equals V. The 3x minus 2 must equal 0. How do we solve for x? Add 2. And then divide by 3. X equals 2/3. All right. Bless you. All right, questions so far? Is it easy or hard? That's pretty easy, huh? Okay, good. It should be. They do get more complicated, so you'll see a couple that are more complicated like this. Here, we have a few things that are being multiplied together that have the same base. These are being multiplied together. What can we do when things have the same base? What can we do to their exponents? Yeah. If they have the same base, we get to add the exponents. We need to clean up this left-hand side before we worry about anything else. So I'm going to keep my base the same, and we're going to add our exponents. 2x plus 1x is 3x. Yeah, negative 1 and a positive 3 gives me a positive 2 equals 32. So we cleaned up the left-hand side. That's very good. And now what I want to do is write things with the same base. Here I have a base of 2. I want to rewrite 32 with a base of 2. What power would that be? 2 to what power? 2 to the 5th is 32. And if you needed to do a list, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, you could do that. Hopefully you know it by now. But, oops, 2 to the 5th. So I'm going to trade out the 32 for 2 to the 5th. And now these things have the same base. If they have the same base, what's true? U equals V. The exponents must also be equal. So 3x plus 2 equals 5. Subtract the 2 and divide by 3. We get x equals 1. Okay? Good? Yeah? All right. Do you have any questions for me? All right. This is CP34. Pass that out.